Hello fellow chemies. Here I am going to talk to you today about colligative properties and Van't Hoff. So first of all, what is a colloid? A colloid, let me draw a picture here, is basically particles suspended in a solvent. Let's call this the solvent. And there's like stuff in it. Yeah. So how is this, like what kind of properties does this give? So we know that you have boiling point, you have freezing point, and you have osmotic pressure, and you also have vapor pressure. If you guys want, I can go into more in-depth analysis of these specific topics, but we're just going to say that these are some of the equations that define each topic. So for vapor pressure, we have Raoult's law, which is the pressure is equal to the mole fraction of A times the pressure of A initial. So the vapor pressure is the same, equals the mole fraction of A in this colloid, and the pressure, the pure pressure of A, like by itself. So then we have the osmotic pressure, which is given by this symbol, is equal to the molarity of RT, R being the gas constant, and T being the temperature in Kelvin, and M is molarity, of course, so that's moles over liters. The freezing point is given by the change in temperature of the freezing point is equal to some K constant times the molality. And I will define molality shortly after I define the boiling point, which is essentially the same. Some constant for the boiling times the molality. Okay, so first let's talk molality. What is molality? It's just another way to define some kind of concentration. So the molality is the lowercase m, or that's lowercase m is equal to the moles of the solute over a kilogram of solvent. So you have a mole of your solute inside a kilogram of solvent. That is what molality is. Okay, so now that we have all of this out of the way, what is the Van't Hoff constant or factor? What people usually say is the Van't Hoff factor, so keep that in mind. Okay, so what is the Van't Hoff factor? The Van't Hoff factor is something that describes the effect of solute on colligative properties as listed above here. And the factor is usually denoted by an I, and I equals 1 plus alpha n minus 1. Now, what is alpha and what is n? N is the number of ions that your thing splits into, the thing that goes in the solvent, the solute. And A is the fraction of dissociation. So how much does this dissociate in comparison to the whole? So fraction of dissociation. This is Van't Hoff. Factor. So this factor is multiplied to each of these equations to describe things that don't, or things that do dissociate. Because if it doesn't dissociate, then it doesn't do anything. Right. So let's take a look at how this would be used in a problem. As you can see here, some of my beautiful art. Let me erase that for you. Okay. So here's an example problem from an online assignment I had recently. So we have 124. We have a 0.124 molality of CCl3 COOH solution, which has a freezing point of negative 0.423 degrees Celsius. And they also tell us that the change in temperature is equal to 0.423 degrees Celsius, and the freezing constant is 1.86 degrees Kelvin kg over moles, or degrees Celsius, sorry. Did I say that? My bad. Okay, so they want to ask us to find the percent deprotonation of the acid. So first, let's just note that this thing goes to this. And we want to find out how much of this turns into this, essentially. So we can break out our freezing point depression equation here. Delta T equals some constant F times the molality times the Van't Hoff factor. Important because we know that this dissociates into two different ions. So let's look at what we know. We know that the temperature is, or the change in temperature is 0.423. So 0.423 degrees Celsius is equal to this constant, 1.86 degrees Celsius kg over moles times the molality given there, times 0.124 molality of, that, I'm not going to write it out, it's too much, times your factor. We'll just leave it at I for now. So I is equal to, and I just did a quick calculation so that you wouldn't have to wait for it. So this is what I got. 1.83, and we know that I is equal to 1 plus alpha n minus 1. So we ask ourselves, how many ions does it dissociate into? 2. So n equals 2. And we don't know this, but this is what we're solving for, right? The percentage of dissociation. So 1 plus 2 minus 1 is 1. Alpha equals 1.83. So naturally alpha equals 0.83. And to get a percentage out of that, alpha times 100 equals 83%. So we get 83% deprotonation. Hopefully you guys learned something today, and if you want to learn more about these colligative properties here, tell me below, and hopefully we'll get some out there before it's too late for you. Alright, thanks for watching. Goodbye.